In today's lesson, we're going to be doing three IXL sections: IXL section Y1, Y2, and Y3. Identify monomials and multiply and divide monomials. We're doing three sections because they're very simple. So first of all, what is a monomial? A monomial is an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. Terms of an expression are parts of the expression separated by plus signs. Remember that x minus y can be written as x plus negative y. A monomial cannot have more than one term, and it cannot have a variable in its denominator. Here are some examples of monomials and expressions that are not monomials. So if we look on the left-hand side, right here we have examples of monomials. So a monomial can be a number, a variable, or the product of numbers and variables, or the product of numbers and variables with whole number exponents. Like if they have an exponent, the exponent has to be a whole number. And if it's a fraction, you cannot have a variable in the denominator. It says it right here. It cannot have a variable in the denominator. All right, so all five of these are examples of monomials. Now here are examples that are not monomials. All right, these two examples are not monomials, they're binomials. Bi means two, right? They're binomials because they have two terms. All right, the first term is 4 and the second term is x. What are terms? Terms of an expression are parts of the expression separated by plus signs or minus signs, all right? Basically. So in this expression, I got two terms. The first term is 4 and the second term is x. And each one of those are monomials. But a mono means one. All right, so a monomial is just one term with no addition or minus signs. All right, so this is not a monomial. This is not a monomial. This one's not a monomial because it has a negative exponent and it could be rewritten like that. And remember that to be a monomial, you cannot have a variable in the denominator. To be a monomial, you cannot have a variable in the denominator. All right, same thing with this one. In today's IXL, they're not gonna get that specific. All right, as long as you understand that this is a monomial, these that I'm underlining, and that these are not monomials, you'll be fine in today's IXL, okay? Así que en español, un monomio es una expresión que consiste de un número o un variable o el producto de números y variables. Y si tienen un exponente, el exponente solamente puede ser un número entero. No puede ser un exponente negativo. Y si es una fracción, no se permite tener un variable en el denominador. Por eso es que esto no es un monomio, ni este, ni este. ¿Ok? Un monomio solamente puede tener un término. Un término. ¿Ok? Los términos de una expresión son las partes de la expresión que están separados por un signo de sumar o restar. Así que, por ejemplo, aquí esta expresión tiene dos términos, el 4 y el x. Esta también tiene dos términos, el x y el 1. Así que para ser un monomio solamente puede tener un término. Alright, so let's look at the examples. They're very simple from this IXL. They're so simple that I have them all on this one slide. Okay, aquí están todos los ejemplos para IXL Section Y1. By the way, this IXL, I did it in less than 2 minutes. That's how easy it was, all right? So you can knock it out in less than 2 minutes as well because it's that simple. Is 2 a monomial? Yes. All the questions are like this, yes or no. Is 3p a monomial? Yes. All the ones on the top are examples of monomial. All right, and all the ones on the bottom, if they're separated by plus or minus signs, that's it, they're not monomials. Si tienen más que un término separado por signos de sumar o restar, no puede ser un monomio. Y si es solamente un número o un variable o un producto de números y variables, sí son un monomio, básicamente. All right, so that's all you need for Y1. It should be easy. Again, you could do it in less than 2 minutes. Okay, este IXL yo lo hice en menos que 2 minutos porque es tan fácil. Ustedes también lo pueden hacer en menos que 2 minutos. All right, let's look at the next one. IXL Section Y2, where you gotta multiply monomials. Okay, este es el próximo IXL Y2, donde tienen que multiplicar los monomios. Alright, so look, this is also very simple. The numbers, you multiply the numbers times the number. The number times the number. So in this one I got 2 times 3 is 6. And the variable times the the variable k, I can only multiply it. I'm going to multiply it with this k, and you end up adding their exponents. Alright, so k times k equals k to the second power. Because when you're multiplying variables, if the base is the same, you just add the exponents. This has an invisible 1 and an invisible 1. So it equals k to the second power. So that's it. That's my answer. In this one, I do 7 times 4 because I multiply the number times the number. 7 times 4 is 28. Okay, multiplico el número por el número y los variables por el variable. Si tienen la misma letra, simplemente se suma los exponentes. So y to the fourth times y to the fifth equals y to the ninth. So that's what I'm going to add right here, y to the ninth. Over here, 3 times 10 is 30. T to the 6th power times t to the 6th power is t to the 12th power. 10 times 7 is 70. S to the 40th power times s to the 6th power is s to the 46th power. I just add the exponents. Okay, sumo los exponentes. Okay, now down here, I'm going to multiply the number times the number. 9 times 4 is 36. Now, when it comes to the variables, I'm going to multiply the a's times the a's. So a to the 7th power times a to the 1st power is a to the 8th power. Again, I'm just adding the exponents. B to the 1st power times b to the 4th power is b to the 5th power. C to the 7th power times c to the 8th power is c to the 15th power. And d to the 1st power times d to the 1st power is d to the 2nd power. That's very simple. All right, over here, 10 times 8 is 80. P to the 17th power times p to the 4th power is p to the 21st power. Q to the 1st power times q to the 50th power is q to the 51st power. And r to the 9th power times r to the 37th power is r to the 46th power. Ok, así que simplemente estoy sumando los exponentes cuando multiplico un variable con el mismo variable. Solamente tengo que sumar los exponentes. Alright, now you're going to have some examples that involve some basic geometry. Okay, you went over this in middle school, so here's a quick reminder. Whenever you have a triangle, to get the area, they're going to ask you to find the area of these triangles. So to get the area of a triangle, you got to multiply 1/2 times the base times the height. In other words, multiply the base times the height, and whatever you get, divide it by 2. I'll say it again. Multiply the base times the height, and whatever you get, divide it by 2. You can think about it that way. Okay, así que para coger la área de un triángulo, tengo que multiplicar la base por la altura y lo que me dé lo divido por 2. O cojo la mitad de lo que me dé. So in this example, I got to do 1/2 of 5 times 2x. Well, 5 times 2x is 10x. And half of 10x is 5x. Because 10x divided by 2 is 5x. All I did is divide the 10 by 2. So that's my answer. All right. Over here, I got to do, to get the area of a triangle, I got to do 1/2 of 9 times 2x. All right. So 9 times 2x is 18x. And half of 18x is 9x. All I did is divide 18 by 2. Over here, I do 1/2 of x times 2x. All right, so x times 2x is going to equal 2x to the second power. 2x to the second power. And half of 2x to the second power, all you're doing is getting half of 2. Half of 2 is 1. So half of 2x to the second power is x to the second power. Ok, la mitad de 2x a la 2 sería x a la 2. Simplemente divido el 2 por 2 y me da 1. El 1 está aquí y es invisible, okay? 2 divided by 2 is 1. The 1 is here, but it's invisible. And the last example with triangles, area equals half of 2x, the base. No, let me write it up here because when I start writing down here, my writing tool starts messing up. Area equals, or maybe it's just messing up everywhere, half of 2x times 3x. Hold on. All right, let me try again. Area equals half of 2x times 3x. All right, so 2x times 3x is 6x to the second power. So if I get half of 6, that's 3. So half of 6x squared is 3x to the second power. Okay? And then the last type of problem you're going to have is where you got to get the area of a parallelogram. That's super simple. You just multiply the base times the height. So a square and a rectangle are types of parallelograms. Well, actually, both of these are squares. And if you just have a parallelogram, you just multiply the base times the height. It's going to be written for you, so you don't even have to think about it. Just multiply the base times the height, okay? Para la área de un paralelogramo se multiplica la base por la altura. All right, so 3x times 3x is 9x to the second power. And 2x times 2x is 4x to the second power. Because you add up the x times the x is x squared. Over here, 6 times 3x is 18x. Like I said, this is very simple. 5 times 3x is 15x. Okay, esto debe ser bien fácil. All right, now let's go to Y3. Out of the 3 IXLs, Y3 may be the most challenging. It's also simple, but it's the only one that you may have to like actually think on a couple of them. All right, so we got to divide monomials. All right, so when it comes to division, you divide the numbers and the variables. If the bases are the same, you subtract the exponents. Instead of adding the exponents, you do the opposite. You subtract the exponents, okay? Cuando estamos dividiendo monomios, los variables, si tienen la misma letra o la misma base, se restan los exponentes, okay? Se hace lo opuesto de sumar, que sería restar los exponentes. All right, so on this one, you got this, 5g to the 8th divided by g to the 8th. This one's simple because g to the 8th divided by g to the 8th equals 1. It cancels out. So the answer is 5. All right, on this one, you got 10 t to the 9th power over t. All right, so 10 divided by what number is here? An invisible 1. 10 divided by 1 is 10, basically. It stays the same. But t to the 9th divided by t to the first power, you subtract the exponents. Resto los exponentes. 9 minus the 1 that's here means t to the 8th power. All right? And by the way, just to make sure you understand, because, well, never mind. I was going to write out all the t's, but that's going to be a lot of t's. Let me just do this one. 10h over 5h. The h's cancel out. 10 divided by 5 is 2. All right, on this one, 3r to the 9th power divided by 3r squared. The 3 divided by 3 gives you 1, so it cancels out. And r9 divided by r squared, subtract their exponents, so you're going to get r to the 7th power is your answer. They get more complicated. These are the easy examples, okay? Okay, now we have some examples with negative exponents. You do the same thing, though. There's like 2 ways to explain it. Let's look at this. All right, first of all, the 2's cancel out, okay? Now look, I said you subtract the exponents. What's negative 1 minus 0? Negative 1. But you can't have a negative exponent in your answer. You can only use positive exponents in your answer. La respuesta solamente puede tener exponentes positivos. So to get rid of that negative sign in the exponent, I got to put the g to the first power on the bottom. So this would be my answer. 1 over g would be my answer. Here's another way to explain it that you may find easier, okay? Otra manera de explicarlo que creo que a lo mejor es más fácil. What if, instead of writing it like that, I get rid of the negative exponent by putting the g to the first power right here, okay? So the 2 divided by 2 cancels out and you get 1. On the bottom, g to the 0 power times g to the first power, add their exponents and you get g to the first power. So you get the same answer that way. Okay, lo que hice ahí es primero, antes de empezar a cancelar, quité el signo negativo en el exponente moviendo g a la negativo 1, poniéndolo en el denominador para quitarle el signo negativo del exponente. Right? This one's basically the same thing. I got 7p to the negative first power over 7p to the 0 power. If I rewrite it like this, the 7's cancel out. So I'm going to put a 1 here. And when I add these exponents, I just get p to the first power. So 1 over p would be the answer. All right, on this one, well, this one's, I put like very easy examples on this slide. On the next slide, they get more interesting. Here you're dividing the same number divided by the same number. So whenever you're dividing the same thing by the same thing, the answer is always 1. Okay, siempre cuando se divide lo mismo por lo mismo, te da 1. All right, so the answer for this one is 1. All right, let's look at some more interesting examples, okay? Aquí los ejemplos son más interesantes. All right, so I got 6k squared over 2k to the negative 6 power. All right, I think it's easiest so that you don't have to deal with all the negative signs. Just rewrite it and get rid of the negative exponent from the beginning. I think that's the easiest way to look at it. Darn it, I solved it. I got confused here. Let me rewrite that. Hold on. 6k squared over 2k to the negative 6. So when I rewrite it, it'll be 6k squared k6. I was thinking about the answer when I was writing this, and I accidentally wrote the answer. All right, so that. If I rewrite it, it's that, without the negative sign in the exponent. Okay, creo que es más fácil escribirlo y antes de dividir, quitar los signos negativos en los exponentes. Así que lo primero que hice es poner k a la negativo 6 arriba para quitarle el signo negativo. Okay, now 6 divided by 2 is 3, and k squared times k to the 6th power is k to the 8th power. I think that's the easiest method. Creo que eso es la manera más fácil de hacerlo. K a la 2 multiplicado por k a la 6 me da k a la 8. Alright, let's look at this one. 7u to the 6 VW over 7u to the 6 V3 W8. All right, let me give you another tip here. Okay, first of all, the 7's cancel out. The u to the 6th power cancels out because you got them on the top and on the bottom. Okay, now look, here's a little tip. Look at the V and the W. They both have a bigger exponent on the bottom. So an easy way to think about this is think about it like this has 3 and this has 1. So I'm like subtracting the 3 minus the 1. You know what? What I'm trying to say is this. If you look at the V's, you got that. V times W on the top, and on the bottom you got V to the 3rd power, which is that, times W to the 8th power. Now I got to do, let me see if I could do all of them. 4, 5, 6, 7, 8. Okay, so look. That's what I have there, VW over V to the 3rd times W to the 8th. So look what happens. If I get rid of this V and this W, which is what's happening, I end up with 1 over V to the 2nd power, W to the 7th power. So what I'm trying to tell you is that an easier way, rather than doing 1 minus 3, which you could do that, you'll get negative 2 and you got to put it on the bottom. I prefer to think about it as this 3 on the bottom minus 1 will leave you 2 on the bottom. And this 8 on the bottom minus this 1 on the top will leave you 7 on the bottom. Alright, that's the way I prefer to think about it. If that doesn't make sense to you, just do V to the 1st power minus V to the 1st power divided by V to the 3rd power. Here's the other way you could think about it. We'll give you that because 1 minus 3 is negative 2, and it becomes that. But all I'm doing is looking at it like if I'm down here, 3 minus 1 leaves me 2 on the bottom. And if I'm looking at it from like down here, 8 minus this 1 will leave you 7 on the bottom. I think that's easier. All right? Hopefully that made sense. Let's look at this one right here. So 9q squared r s to the 6th power t over 9q to the 8th power r squared s t to the 7th power. All right, so the 9's cancel out. Okay, so look, q to the 8th power on the bottom minus the q to the 2nd power on the top will leave you, where can I write? All right, on the bottom with q to the 6th power. All I'm doing is 8 minus 2 is 6, but since the bigger number is down here, the 6 will be on the bottom. Same thing with r squared and r to the 1st power. 2 minus 1 is 1, and since the bigger number is on the bottom, I'm leaving the 1 on the bottom. Now the s is, the bigger exponent is on the top, so 6 minus 1 is 5, and it'll be on the top. And the t's, the bigger exponent is on the bottom, so 7 minus 1 is 6, but it's going to be on the bottom. All right. Over here, 9r to the 9th power s t to the 9th power divided by 3r to the 6th power st. All right, so 9 divided by 3 is 3. R to the 9th power divided by r to the 6th power is r to the 3rd power. The s's cancel out. And t to the 9th power divided by t to the 1st power is t to the 8th power. Almost done. I think this might be... All right, yeah. This slide has the last 3 examples, okay? Estos son los últimos 3 ejemplos. All right, so let's look at this one over here. So we got 2s to the 0 power. By the way, what did I say is any number to the 0 power? Do you remember? Any number to the 0 power equals 1. Don't forget that. Okay, cualquier número con un exponente de 0 siempre es igual a 1. All right. All right, so that's my problem. Now let's rewrite it. First of all, the s to the 0 powers cancel out because the same thing, a number divided by the same number will always equal 1. So that cancels out. Okay, now let's rewrite it to get rid of the negative signs because that'll make it easier to visualize, I think. Okay, déjame escribirlo de nuevo, pero sin los exponentes negativos. So I'm going to have 2 t to the 3rd power times t to the 1st power times u to the 6th power times u to the 1st power. Now the t's just combine their exponents. So that's going to be 2t to the 4th power. Add their exponents, I mean. And same thing with the u's. Add their exponents. That is easy. Please don't tell me that is confusing because it's not. It's easy. Come on. You're just adding, basically. All right. Now let's look at this one. I got 8p to the negative 6th power. Actually, you know what? To save space, let me rewrite it. Let me rewrite it without the negative exponents, all right? Lo voy a escribir sin los exponentes negativos. So p to the 1st power on the top and p to the 6th power on the bottom. Basically, they're switching places. All right, q to the 8th power on the top and q to the 4th power on the bottom. R to the 0 on the bottom. Let me just write it, even though I don't need to, but whatever, just so nobody gets confused. R to the 1st power on the bottom, s to the 9th power on the top, and s to the 1st power on the top, okay? All I did is, if it had a negative exponent, I put it on the other side, okay? Si tenía un exponente negativo, lo escribí en el otro lado. So now here's my expression without any negative exponents, okay? Aquí está la misma expresión, pero sin ningún exponentes negativo. All right, so 8 divided by 4 is 2. All right, the p's, the bigger p is on the bottom. So this 6 minus this 1 gives me 5 in the exponent on the one on the bottom. All right, this 6 minus this 1, okay? Estoy restando este 6 menos este 1. Y como el exponente más grande está abajo, se mantiene abajo, okay? P a la 5. Now the q's, the bigger q is on the top, so this 8 minus this 4 is 4 on the top. The s's, The s's, I add up s to the ninth times s to the first power is s to the 10th power. And the r's, r to the 0 times r to the first power is r to the first power. Which, I don't write that 1, I wrote it by accident. So whatever. My final answer is tq to the 4th power, s to the 10th power, over p to the 5th power, r. Okay, and last example. El último ejemplo. Alright, so let me rewrite it without any negative exponents. Lo voy a escribir sin los exponentes negativos. So I'm going to have 7 t to the 40th power on the top and t to the 7th power on the bottom. U to the 0 on the bottom, u to the 3rd on the bottom, v to the 11th here, v to the 0 up here, w to the 1st power here, and w to the 4th power here. Alright, so now when I simplify that and get rid of, and subtract the exponents, I'm going to have 7 t to the 33rd power on the top, and on the bottom, I'm going to have the u to the 0 power times u to the 3rd power is u to the 3rd power. V to the 11th power minus v to the 0 power is v to the 11th power. Really, you could just erase this. Whenever it says something to the 0 power, that equals 1, so you don't even have to deal with it. Alright, down here, w to the 1st power times w to the 4th power is w to the 5th power. And that's my simplified answer. Alright, so again, we have 3, in case anyone joined us late, we have 3 IXLs today. Y.1, Y.2, and Y.3. We have 3 IXLs because they're very simple. Okay, and we're going to be dealing with monomials in today's class and also in the next class. And then the class after that, we're going to start with polynomials, which is what your next Algebra 1 test is on, polynomials. Alright, so we're going in baby steps. So like I've told you guys before, make sure to keep up with the IXLs. Don't let them pile up because the whole, like I'm slowly building on the previous IXL. And if you let them pile up, then you end up not understanding the same thing in your algebra class. And that's not the proper way to learn. The proper way to learn is to do a little bit at a time. If you do a little bit at a time, it'll sink in and make sense because we're going to practice it a little bit more next class. But if you just let them all pile up and try to do them all later on a weekend, you're not really learning that way. All right, it's just going to be a big blur to you and you're not really going to get it. Okay, anyways, that concludes today's lesson. Make sure to do your IXLs, guys, and I'll see you guys next class. Have a great rest of your day.